that you've been introduced to web automation basics, we will dive into more complicated and realistic testing scenarios. This will force us to think about system and framework design so we avoid duplicate code, simplify our test structure, make tests easy to write and read, and make the framework easy to use and understand. Framework design is crucial because you have other testers and other developers that want to write or update their tests as they make changes to their code. This goes beyond just making it easy to read for the code review. You want to design it so it's easy for people to use as well. We did this a little bit when we refactored smaller functions, like in our coins game. But now we gotta refactor groups of small details into reusable actions that make sense. Let's start by taking a look at my scenarios for the login feature. The first two scenarios are pretty straightforward. Can the user log in and log out? Given the login page, when I click login with a valid username and password, then I land on the products page. My oracle for knowing that I logged in is that I land on the products page. This makes sense, but make sure you define what you mean by landing on the products page. In my case, I will just look for the header that says products, and that will be good enough for me. My last scenario is a lot more involved because I was thinking of different usernames and passwords that a user could enter. But I also wanted to make sure the error they received made sense. So my oracle here is not just that they get an error, but that the error is helpful. That is part of making the experience high quality. If we take a look at this scenario in my test file, I only wrote a single test with a single example. If I wanted to test each of my examples, how do you think we could do it? I could just copy and paste the test function and switch out the inputs and outputs. That is a valid option, but the way we currently have things set up, that would make for a lot of copied code. The other option would be to use pytest's Parameterize feature. Let's add it to our test function. The @ sign means that this is a decorator. Decorators are functions that wrap other functions. But this is outside the scope of this course. For now, just know that pytest has a lot of decorators like this that you can add to your test to provide more functionality. The Parameterize Decorator allows us to feed multiple examples into a single test function, exactly like how we define multiple examples in our feature file. You do this by defining a list of our examples, but I'll paste this to save my poor little fingers from having to type this all over again. Each of these rows is a single example. The first value is the username. The second is the password. And the last one is the error message, or just error. So I will put these names as the first parameter in my decorator. So right here, in a single string, the first is username, comma, the second is password, comma, and the last one is error. The second parameter is the list of examples that map to these names. This is just our examples variable. The very last thing we need to do is add the names we want to use in our test function signature. We want to use all of them, so username, password, and error, and then start using them in the test. So for our username, we'll just type in the username. For the password, and then for our error, instead of this hard-coded username is required, we'll put in the error. Okay, now run the test. you'll see that after the first example finishes, the test runs again using the next example. It will do this until all examples are executed and then print the results. That's amazing! And it's another tool that you've added to your tool belt. Quick question. What is something that all of these tests have in common? It's the first 4 lines. Every single one of our tests are performing the exact same steps. Visit Swag Labs, enter a username, enter a password, and then click Login. But we don't tell people to work with software like that. I don't tell you to go to netflix.com, then enter your username, then enter your password, and then click Login. No, we don't talk like that. I'd just say log into Netflix, and that's it. So even though there are specific interactions to actually log in, the name of the overall action is just log in. Refactoring the details into more human understandable actions will make the flow of our tests easier to write and easier to read because they'll make sense. So far, we've always refactored into regular functions. I want to show you how to refactor things into a fixture function, which is a special function used in testing. Fixtures are functions that can be used to set up a test and then clean things up once the test is over. Let's take Py for example. Py is just a fixture. It spins up the browser, returns it so we can use it in the test, and then after the yield, it does all of this, which is after the test is complete, including closing the browser for you automatically. All of this is handled in a single fixture, and to you, the user, all you see is the word Py. That's what I mean by making things so easy to use, you don't even know that there's a bunch of stuff happening in the background. All right, so how do we refactor test code into a fixture function? Well, I'll show you. Let's grab these 4 lines that we know are the same. Then we'll copy and make a function called login and paste everything in there. We need Pylenium, so let's put in py right here. And the last thing we need to do is add a decorator at pytest.fixture. It looks like any other function, but it has the at pytest.fixture decorator that pytest now sees as a special setup and teardown function. Now we can use it in our tests by adding it to the test function signature. So for this first test, comma, login. And notice how the IntelliSense even sees it. Login. Login does these 4 for us automatically, right? So I can just delete these lines. We'll do the same thing again for the second test. Log in, and then get rid of these 4 lines. There you go. The code is much more concise and only shows what we're trying to test. It's still clear that we are dependent on the login action because it's in the parameter list, and neither of these tests are sharing the same code unnecessarily. But wait. Uh-oh. This login action isn't going to work for our last test because we hard-coded the username and password values. Yes, there are ways to solve this within the fixture, but this time we will refactor this logic into a regular function called loginWith to see the differences between them. So back up here at the top, let's make another function. We'll say loginWith. We're going to need Py, a username, and a password. Paste our code in, and then replace standard user, the hard-coded value, replace it with the username that we'll pass in eventually, and the password with password. Perfect. Now let's update our test to use it. So we'll get rid of all this, and we'll just say login with. We have pi, a username, and a password. Yeah, much cleaner. Let's not forget to update our fixture with the login function too. So back up to the top. We're going all sorts of places. We're going to replace this with just our login with. We need pi. The username is standard user. And the password is secret sauce. Get rid of all this. And we're all done. No need to change the test, by the way, because we only need to make the change in one place, and that'll affect all of our tests. Very, very cool. It's not too shabby for our first refactor of UI automated test. Let's go. The last thing I need to show you is how to store your fixtures. If we wanted to move our login with function to another file, that would be really easy. We could just create another Python file called like swaglogin.py and move it there. Then we would import it into our test file and be done. Fixtures don't work that way. If they are in the same file as the tests, any tests in that file can use it. However, none of the other test files anywhere else could use it. If you want to move our fixture of login to another file so it's more globally accessible, then you need to create a very specific file called pytest.py. This is a special file specifically made for you to store as many fixtures within it as you want. Then any test files that are in the same directory or in any subdirectories can use it. So, for example, if we put a conftest file under chapter 5, all of our test files within chapter 5 could use it. Test challenge 3 and test Google search. However, because the conftest file is within chapter 5, none of the other chapters could use it. If you wanted a fixture that all of the chapters could access, then you could create the conftest file at the project root, the highest level, or maybe within the chapters directory. For now, let's make a conftest file under chapter 5, conftest.py, and let's move our login fixture. I'll just cut this out, cut and paste. We'll leave this red for now because we need to make another file for our login with function. So let me chop this out as well. I'll do Command X to get it out of here. And I'll make another file under chapter 5 called swagactions.py. And I'll paste it in here. Whoa, way too big. Perfect. Back in my conftest.py file, let's start bringing things in. So import this name. I need to bring in pytest. There's the import statement. One more with login with. Import this one as well. Awesome. Inside of test challenge 3, let's clean up a bit. Notice how our first two functions don't have any red squigglies anymore. These login fixtures are already there and they're working. If I got rid of this and said py login, you still see it in our IntelliSense because this test file has access to this conftest.py file. The last bit that we need is down here. This login with, we need to bring it in. Import it, comes up here at the top, and we're done. With that, just take a look at these tests now. Test user can log out. Once we're logged in, click on open menu, then click log out. And we should land right back onto the index.html, which is the login page. We have some examples to drive our tests, so we could do multiple inputs and check multiple outputs as well. And even this test looks very clean too. So in the grand scheme of things, we honestly didn't do that much refactoring, and yet the small tweaks that we made a world of difference with how our tests look, how they feel, and how they read. That's exactly what we want as we're designing our framework. So we're going to take this a step even further in the next challenge. In this challenge, write a test that does the following. Add any item to the cart, check out, and then assert that checkout was successful. As always, make sure to write your feature and scenario first after exploring the app a bit. Then, write the automated test to satisfy the scenario. Everything, including your oracles, are up to you, but make sure to use actions or fixtures, now that you know about them. Your framework design should be simple, and your test should be easy to read and just make sense. Once you're done, we'll wrap up this chapter by learning how we can scrape data off of the page to use it in other places. Good luck!